We know enough about derivatives and exponentials now to actually prove the power rule in its sort of full generality. Remember, at this point, we've proved the power rule for positive integer powers. We've proved it for negative integer powers. And we've proved it for rational exponents, so p and q integers, right? But what about something like x to the pi? Pi isn't a rational number, or x to the square root of 2. Square root of 2 isn't a rational number. Is it safe to use the power rule for these powers? Well, let's check. So let's find the derivative of x to the n. Remember, for the full generality of the power rule, we don't know if the power rule is true yet, so we can't just use the power rule because we don't know if it's true. But what we can do is, right, in calculus, anytime you have an inconvenient base, switch to base e, because base e is nicest for calculus. So what we can do is write this as the derivative with respect to x of e to the natural log x to the n, like that. And this is because x is equal to e to the natural log x. This does assume that x is positive, so that it has a natural log, but if you fiddle with the details, you can make it work for negative x values as well. Okay, so we want to calculate the derivative of, so this is e to the natural log x times n, and remember n is a constant here. Now we can calculate the derivative. So we have an exponential, right, with something in the exponent. So the chain rule says the derivative of this is e to the same thing. And then chain rule says we have to multiply by the derivative of the exponent. So e to the natural log x times n times, now the derivative of natural log x times n. So n is a constant, so the constant multiple rule says we can just write down that n and then multiply by the derivative of natural log x, but that's 1 over x. Okay, so let's pull this n out in front. E to the natural log n, that's x to the n, right? That's just doing this trick backwards that we did forwards before. So n times x to the n times 1 over x. But now we can simplify our exponents, and we get n times x to the n minus 1. And there finally is the power rule for any power, rational or irrational.